Hello, I'm going to review Chapter 7's material on systems of linear inequalities and just graphing the solutions to an inequality. So I'll just get started with a few examples of just one inequality in each of these. We'll deal with parallel lines, the different types of shading on a solution, and how to determine if we should put it even into slope-intercept form or graph it using intercepts. So for the first problems, let's put these in slope-intercept form if they aren't. So with this one, since it's already in the y equals mx plus b form, I can identify that my slope m is the coefficient to x, so 3 over 1. My y-intercept is -1, which is where it crosses the x-axis. Since I have a greater than sign, it's not greater than or equal to, it's just a greater than sign. So that's going to be a dashed line. And since it's in slope-intercept form and it's greater than, it means we're going to be shading above the line. So now that I have these four pieces of information, I'm going to start with graphing my y-intercept, which is at -1. And then I'm going to move in the direction of the slope, which is rise over run. So rise 3, run 1. I'm going to get out my dashed line tool. Okay. And then I'm going to connect these dots. So this is what the line is going to look like. And now we have to do our shading, which is going to be above it. So I'm going to start shading in this entire region, which is the half plane that represents my solution. So just to check one of our answers, I want to look if 0, 0 is in my solution. So it looks like it is graphically. It's in the shaded region. But in order to prove that 0, 0 is part of the solution, I'm going to substitute 0 in for x and 0 in for y. And we're going to check and see if this is true or not. So is 0 greater than -1? That is true, which again, it means that it is part of my solution. On to the next one. So this one is in standard form. 3x plus 4y is less than or equal to -8. So the first step here is to put it into slope-intercept form, which means we're going to need to isolate y. So my first step will be to subtract 3x on both sides. And keeping this in the slope-intercept form, I'm going to have 4y is less than or equal to -3x minus 8. And now what I'm going to have to do is divide everything by +4 here. And that's going to isolate y. So I have y is less than or equal to -3 over 4x minus 2. And I'll do the same thing that I did on the last problem, which is identify what our slope is. -3 over 4. Again, it's the coefficient to x, the number in front of that variable. My y-intercept b is -2, which is going to be our starting point. Since we have the or equal to part of this, so it's less than or equal to, since we have the or equal to part, it's going to be a solid line, which means that any point that is on that solid line will be a solution to the system, or I'm sorry, to this inequality. If I go back a slide and we had the greater than, any point that we would have picked on this line would not be a solution to the inequality, because at the very end of this, if you pick a point, you would end up with something that would say like 3 is greater than 3, which is not true. 3 is greater than or equal to 3, but again, we would need the or equal to part to be underneath. Last thing, since we are in slope-intercept form and I have a less than sign, that means our shading is going to be below. So now that I have all this information, I can go to the graph, starting with the y-intercept of -2. I'm going to be going down 3 and to the right 4. And I also get the question a lot about what if I attach the negative sign to the 4 instead of the 3? Well, this would mean a rise of 3 and a run of -4, which is still going to be on the line. So I'll go grab my line tool and connect these points. Now the only thing is, this should be a solid line. Okay, so it's a solid line, and I'm going to be shading below. And just to check a solution again, I'm going to use 0, 0. Now this time, 0, 0 does not look like it's in my shaded region. So what I expect is when I replace my x by substituting 0 in here and here, I end up with 0 is less than or equal to -8. And we know on a number line that's not true. 0 is actually greater than -8. So since this is not a true inequality, then that means that that point 0, 0 is not part of my solution. Moving on. Last one, also in standard form. This is the last one of the inequalities that we are going to solve. After this, they're going to be systems of inequalities. So with this one, I notice that the coefficient to y is going to be -1. So what'll happen is I'm going to move my 2x over to the other side, and I'm bringing down negative y is greater than negative 2x plus 4. Now when I divide by a negative, you have to be very, 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 very insanely careful to make sure that you flip your inequality. If you are multiplying or dividing by a negative coefficient, so the number in front of y, if that is a negative, you have to flip your inequality, otherwise your shaded region would be on the wrong side of the half plane. And this is actually a minus 4. 4 divided by negative 1 is negative 4. So I'll do the same thing again, identify that your slope in fraction form is 2 over 1. My y-intercept, where it crosses the y-axis, is negative 4. Since it's just a less than, we are going, because it's not less than or equal to, it's just less than, so this is going to be a dashed line. And then again, since it's in slope-intercept form and your y is written first, it's isolated, and I have a less than sign, we are going to be shading below. So I go to the graph, starting with down 4, and I'm moving the direction of the slope up 2 over 1. Again, you could go down 2 and to the left 1. I'm going to get out my line tool so that this graph isn't insanely ugly. Okay, so it's a dashed line, and shaded below means I'm going to be going this way. And again, a good point to pick to check would be 0, 0. And since it's not part of my shaded area, it's not part of that half plane, that means 0, 0 would actually not work in this case. On to systems. So systems of inequalities are different. In order to be a solution, the point needs to satisfy both the top and bottom inequality. So both of these are in slope-intercept form. So I'm going to do the same thing as I did in the last problems by identifying those 4 pieces of information. Starting with the top inequality, the slope is 2 over 3. The y-intercept is negative 6. Since it does not have the or equal to part, it is going to be a dashed line. And it is in slope-intercept form. The y is isolated. It's a greater than sign, so that means I'm going to be shading above. Okay, I'm just going to do the work right away for the other one. So with this bottom inequality, my slope is technically negative 1 over 1. My y-intercept is positive 4. This has the or equal to part, so it's less than or equal to, which means a solid line. And again, since it's in slope-intercept form and it has a less than, we are going to be shading below. So now what I'm going to do is go to my graph with the same colors. I'm going to start down 6. 4, 5, 6 is right here. I'm going to go up 2 and over 3. Do that a couple times. This one is going to be a dashed line, so really crappy. I'm going to try to draw it in. And then same thing going the other way. And then this one is shaded above, so I'll try to make kind of a cleaner graph. This is all my shading right here, and that's for that first, just the top inequality. Now I'm going to change color. I'm going to do this one here in red, starting up 4. And the slope of this one was down 1 to the right 1. So this one had a solid line. So this is going to look really crummy too. Solid line, and this one was shaded below. So I'm going to kind of shade what part of the solution this one included, which keeps going all the way this way. So at the very end, I'm going to darken in the area that's double shaded, and it is all of this right here. This entire area that is shaded twice, which I'm going through again. I'm just kind of darkening this area to represent that this is my solution. So I look at that point 0, 0, which is part of this crazy region that I'm just going nuts on right now. And 0, 0 is part of the solution. So what that means is if you substitute 0 in for x and 0 in for y in both of these inequalities, it would work. The part that I do want to touch up on is this intersection point of our 2 lines. When we had a system of equations, so if I were to put equal signs here, so pretend these were 2 equal signs, I could solve it with substitution. You would solve for an intersection point, and you would get this point, whatever this point is off the graph, would be your intersection point of x and y. If it were a system of equations, that would be your only solution to the system. Now, since it's inequalities, I would ask the question of, is this intersection point a solution? And the answer would be no. And the reason for that is since one of these lines is dashed, that means that every point on this line, even though it looks like it's by my purplish double shaded region, every point on this line is not part of my solution because it is on the dashed line. Every point on the solid line is part of my solution because it is in the double shaded region. So and the solid line indicates that every point on that line is a solution. So since the intersection is made up of a dotted line and a solid line, that is, intersection point is not part of the solution. Next one. Top equation here is, or top inequality is in standard form. So the first thing I'm going to do is subtract 3x on both sides so I can get this into slope-intercept form. And I'm going to divide everything by 2. And let's switch color here. So this one is going to become y is less than negative 3 over 2x plus 6 divided by 2, which is 3. I'm going to break apart my 4 pieces of information. My slope is negative 3 over 2. My y-intercept starting point is up 3. It's positive 3 on the y-axis. I have a less than sign with no equal to underneath it, so that indicates a dashed line. And again, it's in slope-intercept form. It has a less than, so we are going to be shading below. The other one, this looks a little bit kind of weird because it doesn't have that constant term at the end. All that means is that my y-intercept is 0. If there's no y-intercept written, it means really it's 4x plus 0. So we are going to be crossing the y-axis at 0. My slope is going to be up 4 and over 1. I have a greater than sign with no equal to below it, so it's a dashed line still. And this one's going to be above because the greater than. So I'll stick with these colors again on the graph. Starting with the blue one, we are starting up 3. The slope is down 3 and to the right 2. I'm going to get my line tool out this time, and I'm going to draw a dashed line through these points, and I'm going to shade this one below. So this one is shaded in this direction. This is all my shading. This one crossed. That's my bad. That's ugly. I need to fix that. Okay. Other one, you're starting at 0, 0, 0, and this is going up 4 and to the right 1. And this is also a dashed line. So I get the dashed line tool out, straight down here, and then this one was shaded above. So if I look at where this crosses the y-axis, notice that all the points above this, where my cursor is, are greater than that point. So what that means is that your shading is going to be on this side of the line. Okay, and at the very end, again, I'm going to go through and I'm going to highlight this double shaded region, which is all of this stuff right here. And again, since we have 2 dotted lines now, we would need 2 solid lines in order for the intersection to be part of the solution. But since these lines are dashed, that means that that intersection, even any point that is on either of these 2 lines, any point on those lines is not a solution to the system because they are dotted. And the last one of these examples, in both of these cases, we are in slope-intercept form. I'm going to identify my 4 parts. So for the top one, my slope is 1 over 1. My y-intercept is negative 1. This is going to be a solid line because I have the or equal to part here, and shaded below because it's a less than. For the other inequality, my slope is also 1 over 1. So if we have the same slope, that's going to tell us that we have a specific type of pair of lines here. My y-intercept is 4, also a solid line again. And since it's a greater than, we're going to be shading above. So now I'm going to go to the graph, starting with the y-intercept of negative 1. For the blue, we're going up 1 over 1, up 1 over 1. And these are solid lines, so I'm going to have to get out my solid line tool and start shading this. I'm sorry, I'll graph it and then I'll shade it. So my shading is going to be below this line. Again, all the points where you look at the y-axis would be underneath it. Start with shading there. That is going to indicate that it is below that part of the line. So this is all part of the solution to just the top inequality and not necessarily the system. The other one then, switch color, this is going to start up 4. And since we have the same slope, it's going to be an indication that we have parallel lines. So I'm going to go to the line tool, still on solid. Okay. I draw on my lines, and now this one is shaded above. So if you remember going back to the last 2 problems that we had, the solution to a system of inequalities is the set of points in the double shaded region. So this whole area down the middle is always going to be open, and it's never going to be covered with both colors because these are parallel lines that will never touch. So this problem actually has an answer of no solution, which means there is no combination of x and y that would satisfy both of these inequalities. If the inequality would have been flipped on either one of these, you would definitely have a double shaded region, in which case there would be a solution. So don't make the assumption that parallel lines are going to have no solution. It is only if their shading is on the opposite sides, like this one is. So the last problem I want to do then is a problem-solving problem. It's a story problem situation. We're going to create two linear inequalities. We're going to define our variables, and then we're going to graph our solution, and then actually pick a point that works. So the first thing, I'll just read through this. It said Sarah is selling bracelets and earrings to make money for summer vacation. She's charging $8 for bracelets and $10 for earrings. She has enough supplies to make a total of 50 of these bracelets or earrings, a combination, and is trying to earn at least $200. So we want to create and graph a system of linear inequalities to model this situation, and then we're going to identify a solution to the system, and we're going to check it. So a lot of stuff going on here. First of all, we want to figure out what our variables are. So the amount that she's charging for bracelets and earrings is not going to change. She's going to charge one person $8 for a bracelet. She'll charge another person $8 for a bracelet. So the cost is not a variable, but the number of bracelets she decides to make is a variable. So I'm going to let B represent the number of bracelets that she makes, and I'm going to let the letter E represent the number of earrings that she decides, or number of pairs of earrings, I should say, because these will be being sold by the pair. So when I say that we have enough for 50 items, that includes a pair of earrings and like one bracelet. So I'm going to go through the system. The first inequality we're going to create is going to focus on the fact that she can make a total of 50 items. So she can't make 51 items. She can make 40 items because it's under the 50. So that means that a combination of the number of bracelets plus the number of earrings has to be less than or equal to 50. And that's one of my inequalities. The other one is going to be focused on the money, and that's the fact that she's charging $8 per bracelet plus $10 per pair of earrings, and that amount she wants to make at least $200. So like $150 would not be enough. So she needs greater than or equal to $200 in order to reach her goal. So both of these inequalities are in standard form. We're going to graph these actually using intercepts instead of slope-intercept form. So the first thing I'm going to do is label my axes. I'm going to have my number of bracelets down here, and then I will put my number of earrings over here. And I'm going to graph this using intercepts. So what that means I'm going to do is assume that she only sells bracelets. That means I would be substituting 0 in for E, and you would end up with B is less than or equal to 50. So what I'm going to do is go on my x-axis here. I might actually have to change my scale. I'm going to go on my x-axis, and I'm going to change this number once I change my scale real quick. I'm going to change the scale, count by tens, and what I'm going to do is graph where 50 is. So 10, 20, 30, 40, 50, and I'm going to put a point there representing that 50 bracelets that she would need to make her goal then. So this is bracelets. And I'll do the same thing for the earrings. So let's assume that she sells 0 bracelets and only earrings. Well, she would need to sell 50. So I'm going to also just kind of wipe this. It means that, again, her supply amount would allow her to only make 50 of those. So I'm going to count by tens again here. And I'm going to make this inequality first. It says E is less than or equal to 50. And I'm going to put that right here. And since this is a solid line, or I'm sorry, since it has the or equal to, we're going to make a solid line. And it would be shaded below this. If I wrote this in the slope-intercept form, the inequality would still be less than or equal to, which means I would be shading underneath this line. I'm going to do the shading at the very end, actually, just so you can see the other points that I put on there. I'm going to do the same thing for intercepts now with the bottom equation. So if I sell 0 earrings, that means only bracelets. Let's figure out how many bracelets she would need to sell in order to reach her goal. And I end up doing 200 divided by 8, and that means she would need to sell at least 25 bracelets in order to make her goal. So I'm going to go on this axis where the number of bracelets is and go to where 25 is and mark a point. And then what I'm going to do is the same type of setup for the number of earrings. If she sells 0 bracelets and only earrings, I'll figure out how much that comes out to. So if I divide both sides here, it's going to come out to 20. So she would need to sell 20 earrings in order to reach her goal. So I'm going to connect those 2 points with a straight line. And we'll talk about the shading. So in the first inequality, so now I can switch my color back again. In the first inequality right here, we had the fact that she had enough material to make a total of 50. So that meant that all of this area underneath and below that curve represented her amount of supplies. And I'm going to switch color back. The money equation meant that she had to make at least this amount. So that's going to represent all of this area above our second line that we drew. And the double shaded region is going to represent our solution. So every point in this region is going to represent a solution. Okay, so the last step here in our problem, I'm going to scroll this down, is to pick a solution, and then we're going to check it algebraically. So let's assume she makes 10 bracelets and 30 pairs of earrings. So let's see if the point 10, 30 works. So I'm going to try on both of these, substitute 10 in for B and 30 in for E. So in my first inequality, I have 10 plus 30 is less than or equal to 50. So since 40 is less than or equal to 50, it satisfies the first system. And now I'm going to substitute this into the bottom one and do 8 times 10 plus 10 times the 30 pairs of earrings. And again, she wants to meet a goal of $200. So that gives me 80 plus 300. And when you combine that, I end up with 380 is greater than or equal to 200. So she makes $380, so that satisfies it. So again, any point in that region is going to be part of your solution.